Welcome to my audio tips and tricks YouTube channel. The purpose of this video is to share what I've discovered while fine-tuning the settings of a REL T7i subwoofer with a pair of LS35a loudspeakers. The iconic LS35a loudspeaker was designed by the BBC in the mid-1970s for use as a mini monitor in mobile recording vans. It measures 12 inches high by 7.5 inches wide by 6.5 inches deep and is comprised of a tweeter, midwoofer, and two-way crossover in a sealed box enclosure. Several British audio manufacturers were licensed to make these speakers for the BBC, including Rogers and Harbath. In 2015, Falcon Acoustics introduced their own version using new drivers made to the original specifications. This chart is from the Stereophile magazine review article. Those who own an original or one of the many copycat versions can attest to their mid-range magic. However, its 5-inch midwoofer driver cannot reproduce frequencies much below 100 Hz. From this chart, the speaker's sound level starts to decline at around 120 Hz and reaches its half power or minus 3 dB point at around 80 Hz. By 60 Hz, the sound level is quite diminished. Musical instruments can generate notes below 90 Hz. Pianos and pipe organs can reach notes below 30 Hz. Double bass and drums can play notes below 60 Hz. If an audio system can't reproduce these frequencies, then we cannot hear all of the music that is captured on a recording. Without low frequencies, music can sound light and airy, but without any richness of tone. A subwoofer designed for music playback is intended to blend in musically with the main speakers and extend the low frequency response of an audio system. A subwoofer designed for home theater is designed to reproduce low frequency sound effects of movie soundtracks, explosions, jet engines, and the like, often at sound levels higher than for music listening. REL, or REL, is a British audio manufacturer of subwoofer loudspeakers. The T7i is the mid-sized model in the series. The latest version is the T7X. Dimensions are 12 inches wide by 14 inches high by 14 inches deep. It has a front-facing 8-inch driver, a 10-inch passive radiator firing downwards, and is powered by a 200-watt RMS Class AB solid-state amplifier. REL is one of a few subwoofer makers to provide speaker-level inputs as well as line-level RCA inputs. Most two-channel audio components do not provide RCA outputs for connection to a subwoofer. REL recommends using speaker-level inputs and provides a long length of cable to connect to the speaker terminals of an amplifier. The other end is terminated onto a proprietary Nutric Speak-On connector for connection to the sub. This arrangement allows the main speakers to reproduce the entire musical signal. My DIY speaker project follows the BBC research paper entitled "The Design of the Miniature Monitoring Loudspeaker Type LS35a" by H.D. Harwood, M.E. Watton, and R.W. Mills, October 1976. Deviations include not using the original Tygan speaker grill cloth and omitting the felt surround for the tweeter. After consultation with Jerry Bloomfield, the owner of Falcon Acoustics, I chose to use the 23AB crossover, which is different from the one used in their factory-built BBC-licensed LS35a speakers. The treble response of this crossover is supposedly smoother. The REL sub is placed near the left wall, about 3 feet from the front wall. This location does not trigger boominess in my listening room, which is part living and part dining room. In this picture you can see a couple of DIY bass traps in the front corners. These have been mounted along the top front corners. The REL T7i has 3 adjustments: a phase switch, a stepped volume control knob, a stepped crossover frequency control knob with a range from 30 Hz to 120 Hz. Let's talk about why there is a phase switch. There are two ways for a subwoofer to be out of phase with the main speakers. If the main speaker's polarity is reversed, it pushes the cone outwards with a negative signal while the sub retracts its cone. This is out of phase. If the sound wave from the subwoofer is 180 degrees out of phase with the sound wave from the main speakers, the two sound waves will cancel, leaving you with very little bass output in your listening room. The second way for a crossover to be out of phase with the main speakers is if the subwoofer is located well into the listening room at approximately 1/2 the wavelength of a frequency. The wavelength of a 100 Hz signal is 11.3 feet. For the subwoofer to be 180 degrees out of phase with the main speaker at 100 Hz, it would have to be located at the half wavelength distance of 5.6 feet, either in front of or behind the main speakers. To set the phase switch, play a 100 Hz tone and flip the phase switch to hear which setting offers the loudest signal. The correct setting is the loudest one. The frequency response of my mini monitors fall off less sharply than the one tested by Stereophile. Their measurements were done in an anechoic chamber, whereas I am measuring the response in my listening room with the microphone located at the listening position some 10 feet away from the speakers. From this chart you can see the frequency response from 60 to 90 Hz is relatively flat, but -3 dB down from its 100 Hz level. It dips to its lowest level at 50 Hz. I believe this is the resonant frequency of the speaker system. This is reached when its electrical impedance is at its highest and its output level is at its lowest. The response then rises from 50 to 40 Hz before dropping off for good. Also be mindful of the waveform between 100 and 200 Hz, as the sub's crossover may alter the frequencies from the main speakers. With the volume set at the 10 o'clock position and the crossover at the 12 o'clock position, the 50 Hz dip is virtually eliminated, while the level at 40 Hz is a bit high. I compared the response between 100 and 200 Hz to the original response to determine if any frequency shifting had taken place. It appears that the waveform pattern in this range is a bit different than for the mini monitor. The crossover control is an adjustable filter comprised of resistors, capacitors, and inductors. Its purpose is to roll off frequencies above a certain point so that the subwoofer's sound waves don't interfere with the main speaker's sound waves of the same frequencies. The roll-off is gradual, so there will be some blending of sound waves. However, if the sound waves are slightly out of phase, this is a form of distortion. That said, this could be adding a bit of reverberation, which our ears might find pleasant. With the volume set at 9 and the crossover at 10, the frequency response from 27 Hz to 100 Hz seems to be the flattest, within plus or minus 3 dB. The waveform between 100 and 200 Hz appears to be identical to the Falcon mini monitors without the subwoofer. REL recommends a front corner placement where room boundary effects can increase low-frequency sound levels. With a corner placement and volume and crossover settings at the 10 o'clock position, frequency response between 30 and 45 Hz is flatter than at the previous location. The sound level from 27 to 60 Hz is slightly higher than between 70 to 100 Hz. There does appear to be a slight dip at 100 Hz. Some audiophiles might like a louder, slightly more extended bass response that this position enables. So the first thing I'm going to do is use my tablet as a signal generator, and I will launch the EverSolo app for my DMP-A6 streamer DAC. I will set the input to Bluetooth input. Next, I will launch the signal generator app. from my tablet. I'm just going to check to make sure the low and high frequencies are set properly. So the minimum frequency is 25 Hertz and the maximum frequency is 250 Hertz. I'm going to increase the volume. The next thing I'm going to do is use my smartphone with a calibrated Dayton Audio microphone attached to the headphone jack, and I'm going to use this smartphone as a spectrum analyzer. Place this on a tripod. Hopefully it won't fall off. It's great. I'm going to reset the maximum. There we go. Start it, and then I'll start varying the frequency. Some rude noises there. So, learnings. Initial settings were not optimized. With fine-tuning, low frequencies became more integrated with the sound from the main speakers. Mid-range vocals and instruments seemed more vivid and three-dimensional. Below 35 Hz, the REL became unstable, suggesting more power or dual subs could be beneficial for the size of my listening room. In conclusion, I found that using smartphone apps to measure low-frequency response at different subwoofer crossover and volume settings to be helpful in fine-tuning my subwoofer to integrate better with the main speakers and to extend the frequency range of my audio system. I hope some of these tips and tricks will help you to improve the sound of your audio system and to enhance your listening experience. Happy listening.